Up to this point in your math education, we have learned only about what is called real numbers. Real numbers are basically any number that you have used up to this point. It could be positive numbers, negative numbers, it could be zero, it could be fractions, it could be decimals, it could be a square root of some number, and we could have irrational or rational numbers. And up to this point, that's what we've been calling real numbers. And then recently we have learned that the square root of a negative number, such as the square root of -9, for example, we have said that it would be a not real solution. That is not real because we cannot take the square root of a negative number and get a number back out. Because if we take 3 squared, we get a positive 9. We take a negative 3 squared, we still get a positive 9. So we have learned that the square root of a negative number we would call a not real number. And in this lesson, more specifically, we are going to call those type of numbers imaginary numbers. Now, when you begin studying imaginary numbers, we need a place to begin. Okay, where do you start? So we need a basic definition in order to begin our study of imaginary numbers. So we have what is called the letter I. I, I'm assuming, means imaginary. And I equals the square root of -1. This is your fundamental definition of imaginary number. And you need to know this in order to do anything else in this section. If you don't understand this definition, then you will not be able to do the other things throughout this lesson. So commit this to memory. I equals the square root of -1. So from here, we're going to build our mathematics around this definition. So from this point, we want to try to do other operations with this definition. So we will begin by trying to raise this to different powers. So for example, we will raise I to the second power. We're going to square I. When you square I, what we are doing is we are squaring this square root of -1, as you see right here. And we've learned in a previous lesson that a square and a square root will undo each other. They will cancel each other out, and I'm left with what is inside of the radical. And in this case, it is going to be a -1. So if we know our basic definition of I, and we know our basic properties of radicals and exponents, then we can build our study of imaginary numbers around our previous knowledge. And then we'll continue this. If we raise I to the third power, what we can think of it as is I squared times I. Right? We've learned that if you multiply two variables together with the same base and the exponents are given to you, then you can add the exponents. In this case, the exponent is a 2, and then here's an unwritten 1. So I squared times I to the first would equal I to the third power. And the reason I did that is because I squared, we just said, is -1. So in place of I squared, I can put in a -1, and we would get our solution, or simplified form, of -I right here. So I to the third power, we can simplify and say it is equal to -I. Now if we continue this, I to the fourth power, we can break I to the fourth power up as a product of I squared times I squared. Well, we already said I squared is -1. So what we have is a -1 times another -1, which would equal a +1. So we can simplify I to the fourth power to equal a +1. And notice, by the way, this is kind of fascinating, that if you look at I squared and I to the fourth power, we begin with an imaginary number. but when you square it, we get back out a real number. -1 is a real number. Same with I to the 4th power. I is an imaginary number, but when you raise it to the 4th power, it becomes just 1, a real solution. So to me, that's kind of fascinating. You may or may not find that to be as interesting, but imaginary numbers can give you a real solution back out if you raise it to the correct power. And if we continue expanding this to I to the 5th power, I to the 5th would be I to the 4th times I, right? I to the 4th times I would be I to the 5th because you add the exponents. And I to the 4th, we've just stated, is equal to 1. So I to the 4th I can replace with a 1. So what we have is 1 times I, which would just be I. Notice I to the 5th power equals I, which is right back to where we started. And if you were to continue this, I to the 6th power, we would find that it would cycle back through. So I to the 6th power would be the same thing as I squared, which would be -1. I to the 7th power would be the same thing as I to the 3rd power, which would equal -I. I to the 8th power equals I to the 4th power, which would equal 1, and then cycle back through again. I to the 9th power would equal I to the 10th would be I squared, I to the 11th would be I cubed, and etc. So every 4, they're going to cycle back through and get back to the original definition of I. So we've learned how to raise the different powers. Now we're going to use this to simplify. So here we see a radical. And up to this point we've learned that the square root of negative numbers is going to be not real. But now with this new information, what we'd like to do is we would like to simplify by writing this radical with this imaginary component. So what I can do is I can use my laws of radicals, which says that I can separate one radical into 2 radicals. So here we have a square root of -3, which I can think of as a square root of -1 times 3. Or I can break it apart as a square root of -1 times the square root of 3. Right, because with my laws of radicals, when I multiply, I put them back together to be the square root of -1 times 3 to get -3 back out. This is the same thing as square root of -3. And we have learned in this lesson that the basic definition of I is I equals the square root of -1. So I could write this as I times the square root of 3. So I pulled out the imaginary component and wrote that with the letter I. Here's another example. Square root of -49. Now once again, up to this point we have learned that this would be a not real number. Well, in this lesson we've learned that we can pull out the imaginary component. We can think of this as the square root of -1 times the square root of 49. That is the same thing. I can break it apart into 2 radicals. And the square root of -1 is our definition of the letter I, and the square root of 49 is 7. So what we have is I times 7, or 7I. And that would be my simplified form of the square root of -49. Here's one more. We have the square root of -98. And same thing is an imaginary number because it is the square root of a negative number. And what I can do is I can write this with the imaginary component. I can pull out the -1. So I have the square root of -1 times the square root of 98. The square root of -1 we know to be I. And then the square root of 98 we know can break down, and we can think of this, I guess, 2 different ways. But we can think of this as the square root of 49 times 2. And the square root of 49 times 2 can break apart to be the square root of 49 times square root of 2. And the square root of 49 would be 7. So what we have is 7 times I times the square root of 2. If you don't know how to do it that way, the square root of 98 you can break down as a product of 7 times 2 and pull out a group of 7s So we have the 7 times the square root of 2 left over. And that's what we have here. And usually, by the way, we put the I before the radical and after the constant. So it's really not a big deal, the order in which you write the number, letter, and radical, but this would be the best way to write that. So we've learned the definition of I, we've learned how to raise the different powers, we've learned how to simplify. Now we're going to work with multiplying imaginary numbers. So here we see the square root of -4 times the square root of -9. And as you can see, those are both imaginary numbers. So what I'd like to do first is not combine, but pull out the imaginary component. So like we just did, we're going to pull out the letter I out of the square root of -4 and the square root of -9. So what I can do is I can think of this as I times square root of 4 times I times square root of 9. If you can't do that in your head, you could break it down. Square root of -1 times the square root of 4. Square root of -1 is I. So we have I times the square root of 4. And the same thing here. Square root of -1 times the square root of 9. This would be I times the square root of 9. And then the square root of 4 we know is 2. And the square root of 9 is 3. So what we have is 2 times I times 3 times I. Well, 2 times 3 would be 6. I times I is I squared. And now remember, I squared, based off our definition, remember I is the square root of -1. I squared would be the square root of -1 squared, which would just be -1. So I can simplify this I squared to equal -1. So what we have is 6 times -1, which would become -6. Now take note that this is the correct process for simplifying or multiplying imaginary numbers, and that is by pulling out the imaginary component first and then multiplying. Because that is a different solution than if you were to try to multiply first. So for example, if you were to combine the -4 and the -9 to get the square root of -4 times -9, then you're going to get the square root of a positive 36, which would equal a positive 6. Notice that is a different solution than -6. So take note, you want to pull out the imaginary component first. Let's look at one more example with multiplying. Here we see I times the square root of 3 times I times the square root of 7. So when you're multiplying, the i's can combine, and you would get I times I equaling I squared. And the square root of 3 times the square root of 7 you can combine to get the square root of 3 times 7, which would be 21. And then, remember I squared, you can simplify I squared to be -1. So what I have is -1 times the square root of 21, or just negative square root of 21. Now let's work with dividing. With dividing, if you have 2 divided by 3i, this looks pretty much okay, but the only thing is that our standard way of writing fractions is we cannot have a radical in the denominator. And this I is a radical. It is the square root of a -1. So to get rid of the radical, I need to multiply by the radical. So what I'm going to do is I'm going to multiply the top and the bottom of this fraction by the letter I. So now what I have is 2 times I over 3i squared. And I squared, we said, is -1. So what we have is 2i over 3 times -1, or 2i over -3. And that is my solution. Or you can just write that as a -2/3 I, same thing. Here's another example. We have 6 over the square root of -2. And you want to get rid of the radical in the denominator. So remember, first step is always to pull out the imaginary component first. So I could pull out the negative, so I can write this as the square root of -1 times the square root of 2. The square root of -1 is I. And now to get rid of the radical, we need to multiply by that I times square root of 2. And we do that for both the numerator and denominator. So now for the numerator, we have 6 times I times square root of 2, which would be 6I squared of 2. And then the denominator, you have I times I gives you I squared. And the square root of 2 times the square root of 2 would give you the square root of 2 times 2, which would just be 2. So what we have is 6I squared of 2 over 2 times I squared. Okay, and then from here, the I squared, we can write that as negative 1. So what I have is going to be 2 times a negative 1, which would be a negative 2. And then I can simplify the 6 and the negative 2 by dividing. And I get a 3 over negative 1. Or you could just write that as a negative, and then 3 times I times square root of 2. And that is my solution. So we've learned how to simplify, we've learned how to multiply and divide. Now we need to work on adding and subtracting imaginary numbers. Now when you add and subtract imaginary numbers, it is basically the same thing as adding and subtracting variables. Because if you had 5i minus 2i plus 3i, what we need is like terms to combine. Well, the I is part of the term. It makes a term similar or not similar. So here we have 5i, negative 2i, and 3i. Those are all similar because they have the I with the term. So I can just subtract and add as normal. 5i minus 2i gives you 3i. 3i plus 3i would give me 6i. Now here's another example where we treat the addition and subtraction same way as we would with variables. So what I can do, because you're adding, I can just get rid of the parentheses, where I have 2 plus 4i plus 3 minus 5i. And the 2 and the 3 can combine to give me 5. 4i and then minus 5i would give me a negative 1i. So what I have is 5 minus 1i. Here's another example where instead of adding, we're going to subtract. Now when you subtract and you have parentheses, what we are doing is we're subtracting the 3 and subtracting a negative 5i. So when you subtract a 3, you have minus 3. And when you subtract a negative 5i, we get a positive 5i. And now we can combine, where now we have 2 minus 3 gives you negative 1. 4i plus 5i gives you 9i. So my solution would be negative 1 plus 9i. Now here's another example where we first want to simplify and pull out the imaginary component. So what I can do is I can break apart the square root of negative numbers to get the square root of a negative 1 times the square root of a positive 16. And the square root of negative 49 I could break up as a square root of negative 1 times the square root of positive 49. And the square root of negative 1 we know as I, so we have I here and here. And the square root of 16 is 4, and the square root of 49 would give you 7. So what I have is 4i minus 7i, which can then combine to give me a negative 3i. And that is my solution. Now, what if we have radicals and imaginary numbers put together? So for example, I times the square root of 2 plus 3i times the square root of 2. Now once again, when you are adding and subtracting, we need completely similar terms, where in this case, we need the I and the square root of 2 to be similar. So over here we have the I squared of 2, and then with the 3, we have the I squared of 2. So those are like terms because they both have the I square root of 2 component. The first term has 1 I square root of 2. The second term has 3 of them. So you add those together to give me 4 I times the square root of 2. Now if you had something else over here like a plus maybe I square root of 3, that would not be a like term because the square root of 3 is different than the square root of 2. Those are not like terms. Now when you're simplifying with variables, we do the same exact thing, where nothing has changed except now we have number and variable component. So what I like to do first is simplify by getting rid of the negative inside of the radical. So I can pull out that negative component. When I pull out that negative 1, this becomes an I, this becomes an I. And then the other parts, 25x squared, if we take the square root of 25, we get 5. And the square root of x squared, well, the square root and the square will cancel each other, and I'm left with just the x. So this becomes a 5x. And then over here, the square root of x squared, the square root of the squared will cancel each other out, and I'm left with just an x. So what I have is 5xi plus 1xi, and once again, we need like terms. So here we have xi, here we have xi, so therefore those are like terms. So I can combine them, and I can get 5 plus 1, which gives me 6 times xi. Here's another example along the same lines, where I need to pull out the negative component first. Okay, pull out the negative component, and then I can multiply the radicals. If you don't pull out the imaginary component, you're going to get a wrong solution. So I can pull out the negative component, and when I do that, I will get an I out here, which gets rid of the negative, and then I have the square root of 6y. The second radical, I can pull out an I, and I'm left with a positive 2y inside of the radical. And then from here, I can take I times I to get I squared, and then I can combine the two radicals, 6y times 2y, combined into 1, I get 12y squared. Now the I squared is the same thing as negative 1, and then this 12, the square root of 12, I can simplify. So I can break apart the 12 as a product of 2 times 2 times 3. And now I can pull out groups of 2 items. Here we have 2 2's. So I can pull out 1 2. And then I have 2 y's. So I have y squared. And the square root of y squared, once again, will undo itself. And I'm left with just a y left over. Or you can think of it as, there's 2 y's. I can pull out 1 y because I have one group of y's. And then the y's are now gone. Either way, we get 2y on the outside along with the negative 1, and the 3 is left over on the inside. So my solution would be negative 2y times the square root of 3. And it's not 2y minus 1, by the way. This is being multiplied. 2y times the negative 1. Okay, now we're going to work with solving quadratic equations with imaginary numbers. So here we have an example, 2x squared plus 19 equals 3. Now one way that we can solve a quadratic equation is we can get the x squared term by itself and then take the square root of the x squared term. And it works in this case because there is no x term, whereas before we've had situations where it was 2x squared and then maybe like 1x and then plus 19 equals 3. Where here, because you have the x term, you want to try to factor that. But here there is no x component. All I have is the x squared term. So what I can do is I can solve this for x by subtracting 19 over, which gives me 2x squared equals negative 16. And then divide both sides by 2, where now I have x squared equals negative 8. And then now that the x squared term is by itself, all I need to do is get rid of the squared by taking the square root. So I take the square root of both sides. I now have x equals a positive or negative square root of negative 8. So I've solved it, and now I just need to simplify using my imaginary numbers. Because I have a square root of negative 8, I can pull out the negative component and get the square root of negative 1 over here times the square root of 8. And what I have down here is showing the fact that you have plus or minus, so it's going to be a positive square root of negative 8 or a negative square root of negative 8. But when I break it apart as a product of two radicals, the square root of negative 1 is just I. So if I times the square root of 8, and the square root of 8 you can break apart as a product of 2 times 2 times 2, which you can then pull out a group of 2's, and I'm left with a 2 on the inside. So my solution would be 2i times the square root of 2, which would leave me with a positive 2i squared of 2 or a negative 2i squared of 2, because our solution was a positive or negative square root. So we'd have two solutions for this problem. Okay, now we're going to finish off with working with multiplying with binomials and then with dividing by a binomial. And once again, all the concepts are the same. The only exception is that we now have an imaginary number component. But when you multiply, we're still going to distribute the 2 and the 4i. 2 times 3 would give me a 6. 2 times a negative 5i would give you a negative 10i. 4i times 3 would give you 12i. 4i times negative 5i gives you a negative 20i squared. And then from here, we just want to combine like terms, negative 10i and the 12i. And the only thing that's really different is right here, the I squared. Remember, I is the square root of negative 1. I squared would be the square root of negative 1 squared, which would be just negative 1. So what I have is negative 10i plus 12i, which would give me a 2i. And then I squared would be a negative 1. So then negative 20 times negative 1 gives me a plus 20 right there. And 6 plus 20 would give me a 26. So my solution, when I multiply, would be 26 plus 2i. Now one more example with multiplying. Here we see 2 minus 4i squared. And I'm showing this because many people will just take the 2 and try squaring that, and then take the negative 4i and square that. But what happens is people forget that this is the same thing as saying 2 minus 4i times 2 minus 4i. And many people will miss the third term in here. Because what I have is going to be 2 times 2 would give me a 4. 2 times negative 4i would give you negative 8i. A negative 4i times 2 would give me another negative 8i. And negative 4i times a negative 4i would give me a positive 16i squared. So if you do not multiply like I just showed you, then you will not get these two terms in the middle that combine. So don't forget to multiply when you get 2 minus 4i squared. Multiply by itself. But then negative 8i and negative 8i can combine, and you get negative 16i right there. And then I squared, don't forget, is negative 1. So then 16 times negative 1 is negative 16. 4 minus 16 would give you a negative 12. So we get negative 12 minus 16i. And a little side note, it's usually best to write imaginary numbers, such as binomials, where you have the constant term first and then you have the imaginary component second. Not a big deal, but it's usually best practice to write it in that format. And then lastly, we have dividing imaginary numbers dealing with binomials. So here we have 2 over 3 minus I. And the objective is we want to get rid of the radical in the denominator. It is best practice to not have the I or a radical in the denominator. Now we need to get rid of that I in the denominator somehow. And in this case, because we have a binomial down here, to get rid of a radical, what I need to do is multiply by the conjugate when there's two terms down here. So the conjugate of 3 minus I would be 3 plus I. So I multiply the numerator and denominator by 3 plus I. So for the numerator, if I take 2 times 3 plus I get 2 times 3, and then 2 times I, which gives me a 6 plus 2i. And then the denominator, I have 3 minus I times 3 plus I. 3 times 3 is 9. 3 times I gives me 3i. And then negative I times 3 gives me negative 3i. And negative I times I gives you a negative I squared. And that's what I see right here. 3i minus 3i would cancel. I squared is the same thing as negative 1. So what I have is in the denominator 9 minus negative 1, which gives me a 10. And then lastly, I can reduce. I can divide every part by a 2. Divide 6 by a 2 to get a 3. 2 by 2 gives me a 1. 10 divided by 2 gives me a 5. So my solution would be 3 plus 1i over 5. So to recap this lesson, we have learned how to define the letter I, working with imaginary numbers. We've learned how to raise to different powers. We've learned how to add and subtract and multiply and divide. And that concludes our lesson for today. We will see you next time.